Hey guys, today we're going to start with a warm-up where you are labeling the sides and the ratios given the sine of A ratio. So we have draw a triangle ABC, so I have a triangle here for you where angle B is the 90-degree angle. So it doesn't necessarily matter where I put A and C. So it says the sine of A equals 12 over 20. So that means that 12 is the opposite and 20 is the hypotenuse. So just a reminder. We have SOHCAHTOA, so sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So from sine A, as that's my reference angle, opposite of sine A would be 12, that's my opposite, and my hypotenuse directly across from the 90-degree angle would be my hypotenuse. So it says identify the cosine of A. So in order to find the cosine of A, we need the adjacent. The adjacent doesn't have a value there, but when I have two side lengths and I know it's a right triangle, I can use the Pythagorean theorem to solve for the missing side. So a squared plus b squared equals c squared. A squared plus 144 equals 400. Subtract 144 on both sides. 400 minus 144 is 256. A squared equals 256. Take the square root of that value, and then the square root of 256 is 16. So A equals 16. So the adjacent side is 16. So the cosine of A is 16 over 20. And you always want to make sure that you can reduce that fraction as much as possible. So 16 over 20 is 4 over 5. Now this here is some of the notation that we started to see for complementary angles, or for cofunctions, So if the sine of A is 12 over 20, then the cosine of the angle that is complementary to A, which is denoted as 90 minus A, would also, by definition of cofunctions, have the exact same ratio as what we saw here in sine of A. Okay, tangent of B is opposite over adjacent. So looking now at B, AB is my opposite and BC is my adjacent. So that's going to be 16 over 12. And tangent is actually the only trig ratio where you can get a ratio bigger than 1 because you're not necessarily putting it over the biggest value of the hypotenuse. So steps for solving: label the sides based on the given reference angle. So that's talking about labeling your opposite, adjacent, hypotenuse. Determine which of the three trig functions you can use. Set up an equation in the format of trig function of the angle equals the ratio. So you should have this equal sign each and every time. And then you're going to solve for x. So for example, if 32 is my reference angle, I'm going to go ahead and just label all my opposite, adjacent, and hypotenuses. So opposite, adjacent, hypotenuse. So in this case, I've got an angle, I've got something by the adjacent side, and I've got something by the h. So in terms of my trig functions, I have an a and an h, which is cosine. So I'm going to write it like this: cosine of 32 equals x over 17. And what you're technically doing here is you're cross multiplying. So I'm multiplying x times 1, and I'm multiplying 17 times cosine of 32. So x equals 17 cosine of 32. I'm going to put it in my calculator just like that. 17 cosine 32. It's going to give me a decimal, and that's perfectly fine. Let's round to 2 decimal places, 14.42. Okay. Now, another little acronym to remember when you are setting up your problem here is when x is high, we multiply. So when x is on the top, I'm multiplying the cosine trig function by 17 by that bottom hypotenuse. Okay, for this next example, we have, here's our reference angle. That's the angle I'm given. Opposite, adjacent, hypotenuse. And again, I'm just going to jot this down, SOHCAHTOA. So this time, I've got an opposite and a hypotenuse. So that means I'm going to use the sine function. So the sine of 33 equals opposite, which is 14 over x. Notice that this time the x is on the bottom, but we can still just treat it like we're cross multiplying. So 14 times 1 equals x times sine of 33. Now sine of 33 are grouped together, so you can't undo that sine of 33. So 14 equals x sine 33. And what we're going to do is we're going to divide by the sine of 33 on both sides. So x equals 14 over sine of 33. Again, I can't break up that sine of 33 with just a normal trig, so that's going to give me that x equals 25.71. One thing that you can always check for to make sure that you're correct in what you're doing is that if I'm solving for the hypotenuse has to be longer than the sides that you were given. So I'm going to leave this up to you. You can go ahead and try to solve these on your own, and you can check on the answer on its learning to make sure that you solve these correctly. But I'm going to go on to one more problem before you get to your homework, and that's this guy. So it says find BD. Find BD. So in order to find BD, I'm looking at two different right triangles. So let's see if I can draw this without getting too confusing. So here's one right triangle, and then here's my next right triangle. Okay, so I need, right now the green triangle only gives me the angle, so I'm missing like a side length. But in the blue triangle, I'm given an angle and a side. So I can solve for BC by labeling that x. And in that case, I have opposite, hypotenuse, which is going to be sine. So sine of 25 equals x over 30. When x is high, I'm going to multiply. So 30 times the sine of 25 equals x. 30 sine 25. That's going to tell me that x is 12.68. So 12.68. Now, I've got one of the sides that I need in order to solve for the green triangle. So for the green triangle, we now have the opposite, and what I'm ultimately solving for is that yellow piece, which is the hypotenuse. So sine of 50 equals that 12.68 that we just solved for over the hypotenuse. So I'm going to label that as x. So now that's my new x. So x is on the bottom, so we're going to actually switch and divide. You'll notice that you're starting to use the same patterns every time you set up these side lengths. That when x is on the bottom, the trig function is going to end up on the bottom when you're solving algebraically. And when x is on the top, the trig function and the side are just simply multiplying together. Okay, and I got x equals, which x again is BD, 16.55, and that's ultimately what I was trying to solve for. So there will be some cases in your homework where you're having to kind of set up this multi-step problem, solve for a missing side. And in this case, if you look at number 10 on your homework, you're going to be finding the area. And again, area is base times height. So just real quick, here's the base. And this dashed blue line is my height. So good luck working on your homework. Make sure to check your answers here and let me know if you have any questions.